Okay, this is the part 2 of the algebra review, working on question 18 here. So if we look at this problem, it says find the value of each variable to the nearest tenth, then find the perimeter of the triangle. Okay, so we're going to be looking from 55 degrees, and we need to find A and C. So you have to go through what you know and realize that this is a trig problem, and you have to use SOHCAHTOA. You have to. Okay. So let's start by finding one of the variables, A or C. Okay, so if we look at this now, we don't want to mistake A for the adjacent. They just labeled it A and C. So let's start with C. We know C is the hypotenuse. Okay, we know that the hypotenuse is the longest side of the triangle. It's opposite the right angle. Okay, well, they give us 21, and 21 is, compared to 55, it's adjacent. I'm just going to write adjacent, or abbreviate adjacent. So we're going to use the one that has H and A in it, and that's the COT, or the cosine. And you write it out this way. You need to show your work on the test. The cosine of 55 degrees is equal to the A. Okay, so a cosine of 55 is the adjacent side, which is the 21, over the hypotenuse, which is C. We don't know what C is. Okay, and then we have, we said the variables on the bottom divide by the one that has a lot of stuff in it. That's one way to remember it. So to get this answer, you're going to divide 21 divided by cosine 55 degrees. And you can do that on your calculator. Okay, so 21 divided by the cosine 55 degrees. I got 36.61. That sounds reasonable for an answer. Why is that reasonable? Because this is 21, so 36.6 says round to the nearest tenth. It seems reasonable for C. Okay, so C is 36.6. Okay, now that was just to find C. So if this is the final exam, that's part of the question. You still need to find A, and it's done similarly. Okay. Now A, even though it says A, it's really the opposite. It's the opposite side of the 55-degree angle, because it's across from it. So we're gonna use, or we need O, something with an O in it, and something either with an A or an H in it. Now, since they gave us the 21, let's use that, because I don't want to rely on the fact that I might have made a mistake here. We're hoping we didn't. So we're going to use so, okay, for this one over here. So the sine of 55 degrees is equal to the O, the opposite, which is the A, which we don't know. So again, that might mess people up. If you have to put an X there, put an X. Put a variable X there. X over H, and I just said I was going to use 21, but I didn't. So let me just use this one, 36.6. Okay. So we're going to multiply that. I'm going to get 36.6 times the sine of 55 degrees. Okay, we're going to do that on a calculator. Let's say 36.6 times the sine of 55, and I get 29.9. Let's call it 30. Approximately 30 for that. Now, if I did it the other way, I could have done it like I said to begin with, and then I changed my way here. I could have done the tangent of 55, but this time I would have my O, which is A, which I'm now going to call X, over my A, which is 21. So if I do that on my calculator, I should get around 30 also. So if I do, so X is on top, multiply, and stop. If I do that on my calculator, I should get the same answer, 21 times the tan of 55, and I get around the same answer, which is approximately 30. It says to the nearest tenth. That one did round to 30, and the previous one rounded 30 also. Yes, they both round to 30. So either way you do that, you get 30 for this answer here. Okay, not done yet. Okay, now we have the three sides. Now it asks for the perimeter. So this is the part B part. It wants the perimeter. So on the perimeter, we need to add, the perimeter needs all sides added up together. So it would be A plus B, they don't give you B, sorry. Let's call it A plus 21 plus C. So in our question, we got A was 30 plus 21 plus 36.6. Again, you could use your calculator for this. It looks like 87.6. So that's 87.6, and now let's just check do they give us a unit of measurement? No, they don't. So we could just say 87.6 units. This is a word problem. You don't necessarily have to do Fini 5 on it. You could say perimeter is 87.6 units. That's units. Okay. Okay, this is number 19 of the algebra review. Tasha is planning an expansion of the square flower garden in the city park. If each side of the original garden is increased by 7, the new total area of the garden will be 144. Find the length of each side of the original garden. Now, we've seen this question before. We start off with the original garden, which is a square, and you're going to increase it to a larger garden by adding 7 to it, 7 meters. Okay, so if this is the original garden, the new garden would be 7 meters longer and wider. Okay, so in this area, it says the new total area of the garden will be, so A will be 144 meters squared. Okay, so we have to take what we know from this and figure out what x is for over here. Okay, so we know that area of a square, well, area of any quadrilateral is base times height. Okay, in this particular case, it's a square, so it's going to be side times side, which is side squared. Okay, either one of these formulas will work for you. Okay, so if we do x plus 7 times x plus 7 equals 144, so x plus 7 times x plus 7 is 144. So again, we're what we know over here is side times side equals area. Okay, so we have to solve this. Now there's a couple ways to solve this. You could FOIL this out, bring the 144 over, and factor it and solve it using quadratic formula, or factor it and solve it using the shortcut method. Or we could do this. We could realize that x plus 7 times x plus 7 is x plus 7 squared. And then you have to realize, how do you get yourself out of this problem? Okay, so the best bet here is to realize that you can get yourself out of a jam here by taking the square root of both sides. When you square root both sides, that gives you x plus 7 equals square root of 144 is 12. Then I can just subtract a 7 from each side, and I get x equals 5. So the original dimensions are 5 meters. Okay, so a couple of things here. First of all, we should have defined our variable at the beginning. X equals the side of the original ORG park. Park. Original park. So down here, x equals 5 meters, and that should be the side of the original park. Well, let's see if it checks out. Is 5 plus 7 times 5 plus 7 equal to 144? And yes, it is, because 12 times 12 is 144. That's a quick check. That's an acceptable check. And then you would write your answer out. The side or length of the original park is 5 meters. Was it a park or I think it was a garden? Is 5 meters. Sorry, I had some interruption. So it is a garden. Sorry about that. Garden. Side of the original garden is 5 meters, and each one is 5 meters because it's a square. So we could write the sides of the original park. The original gardens are 5 meters. Okay, so for time purposes, I'm just going to cross that out and write it like that. So I'll back this out so you can see the whole thing. So this is the type of work that needs to be shown on the final exam in order to get full credit for this question. It's a very doable question, as in it makes sense. You're starting with a square up here. You start with a square, you add 7 to each side. You do this area formula. You get yourself out of here by doing the square root of both sides. Get a nice answer and move on to a check and answer the question. Moving on to number 20. Another word problem. It's done a little bit differently. And I think on the exam it says do 55 on this, and that's fine. Or just show your work. Basically, 55 means show your work. Define your variables, draw a picture, write out your answer, check your answer. So arrange your spots of forest fire while on a 45-meter observation tower. So you just have a side that says 45 meters, or just 45. The angle of depression from the tower to the fire is 12 degrees. So now you think of angle of depression, you're going to have a triangle. The angle of depression is here at 12 degrees, which transmits down to here as 12 degrees. Okay? To the nearest meter, how far is the fire from the base of the tower? Now, it doesn't say how far is the fire from the guy on the top of the tower from the base, so we're looking for this value right here. Now, why are both angles the same? Because basically we have here is two parallel lines cut by a transversal. And what ends up happening is you have alternate interior angles, and they are congruent, and we learned that last year, and you'll see it again next year. So let's keep going with this question. We need to find, we still need to find x. So we have our setup. So x could equal how far the fire is from the base. We could just write fire from base. Okay, so we need to set this up. We got to figure out what to use with this. Again, we're given an angle. We had to draw our picture ourselves. So we have to figure out what x is. Well, again, we're going to use SOHCAHTOA for this. And again, on the exam, show that you know what's going on. Write SOHCAHTOA out. Figure out which one to use. Well, I'm looking from the 12's point of view, and across from the 12 is its opposite. Next to the 12 are two sides. One of them's the hypotenuse, And I'm not going to use the hypotenuse, so I almost don't even want to label it. That'll disappear in a second. And I need the adjacent side. So we're going to use tangent. And again, we know how to fill this in. Tangent of 12 degrees equals the opposite over the adjacent x. Now the shortcut to this is when x is on the bottom, divide. Well, divide by what? Well, by whatever has the most here. I say the lottom, which is not really a word. So I'm going to go 45 divided by the tangent of 12 degrees. Now, for those of you using a calculator like this, make sure you're in the right mode. So make sure you're in the right mode on your calculator. And then I could just punch in 45 divided by the tangent of 12 degrees. Enter. I get 211.7. I don't know if it said to the nearest meter, it says here. So if I look at my calculator, to the nearest meter, 211.708 is going to round to x equaling, well, approximately 212 meters. I think it's in meters here, I believe. Yes, meters. Now, what do I mean by make sure you're in the right mode? The right mode means you turn on your mode or push the mode button, and this says the degrees is lit up instead of the radians. And to get out of that, you just go to quit. Okay, so I'm in the right mode, and my answer makes sense. So that's the check on this one. The check on this one is this answer makes sense because it's less than the 45 degree length. It's not the best check in the world, but it's a reasonable answer. Okay, so you need to write in a sentence, the tower is 212 meters away from the fire. Okay, looking at number 21, the area of a playground, okay, we're dealing with a playground, is 336 yards squared, or square yards. The width of the playground is 5 yards longer than its length. Find the length and width of the playground. This should say a rectangular playground, so you can very easily draw a rectangle. Okay, that shouldn't be a stretch for you. You can label the length and the width. And we could even label this as length and W is width. And you could go either way. We're just setting up the problem. The width of the playground is 5 yards longer than the length. So technically, yes, this thing should be turned on its side like this. Okay, because the width is longer than the length. So it says the width is. Well, the width is W, and if it's 5 meters longer than the length, the width is 5 meters longer than the length. Your job is I'm going to put L for length. How do I write 5 meters longer than the length? Well, or how do I write this in math terms? W is 5 longer than L. So W, not only is it W equal to the width, it's also equal to 5 plus L. And L, length is just equal to L. Now, because you are taking math before, you know the area of a rectangle is a base times height or length times width, whichever we want to use here. So let's use what we got here. We know the area is 336, and that's equal to the length, which is L, times the width, which is, we're not going to use W, we're going to use 5 plus L, or L plus 5. Either way is okay, because it's more than. Now, your job is to use 9th grade math on this, which means you need to distribute the L. Right, this is one way to do it. So this is going to be 5L with the coefficient in front plus L squared. Okay, you now have a quadratic. To solve a quadratic, as soon as you see quadratic, you need to go, how do I solve a quadratic? Well, standard form. Standard form. Well, what's that? AX squared plus BX plus C equals 0. This allows us to factor it and or use this quadratic formula. Okay, so I got to move this 336 over to the other side, and I got to arrange these terms in order from squared to the first power to just the number by itself. So the L squared is going to go first. Plus 5L comes next. And then when I bring this over, I got to subtract 336. And now it equals 0. Now we can use the quadratic formula on this if you choose to. You can go through and say A equals 1, B equals 5, C equals negative 336. Or you can factor this by triple starts with 3, 2 parentheses, use the chart. I believe we figured this out in the other class, and it was, I want to say 21 and 16. Okay, so plus 21 minus 16. Now that might be tough for you. If it is, then use the quadratic formula. Okay, this result here becomes L plus 21 can equal 0, or L minus 16 can equal 0. And when we solve these two equations, we get L equals negative 21 and L equals 16. We're going to throw out this one because it's negative, and we're going to go with the 16. Okay, well, if we go back to the beginning, we said, well, W is 5 more than L. Well, if W equals L plus 5 and L is 16, then W should be 21. Okay, well, let's see if it is. So now I'm going to do my check. Write the word check. At full credit. It's easier for me to grade. I could see it. We get on with life, and you have a nice summer. So I'm going to do 16 times 21, because length times width, and does that equal 336? And you know it does because you just figured that out. And it does check out. Okay, so we can write the length of the, what are we dealing with here? Park or garden? Playground. Playground, I'm just going to put PG. The length of the playground is 16, I believe we're in meters. Oh, no, we're in yards. Oops. 16 yards. And the width is 21 yards. Okay, so again, we step back and look at this to see how to get full credit for this exam. I drew a picture, I defined my variable, I set it up, I solved it, I checked it, and I answered it. I finifyed it. So when we get our answer, 16 and 21, which should be the length and the width, we're checking it to see if it's equal to the area that was given. And then we can write out our statement and be confident that it's true. Okay. Looking at question number 22, I don't think I copied properly on here. I think this is an equal sign. So it says find the value of x. Well, we're given a triangle with two sides, and the sides are the same, and we're given the area of the triangle. So you have to go back and say, well, the area of a triangle is 1/2 the base times the height. And in our situation here, we can fill in 53 because it's the area. We half, or we could use 0.5. The base times the height would be x times x. Okay, and that cleans up even more to, we could say 53 equals 1/2 x squared. Right, because x times x is x squared. Now we have to solve for x. And in order to solve for x, we have to multiply. We got to get rid of this 1/2. The way to get rid of 1/2 is multiply both sides by 2. And you get 106 equals x squared. Okay, and then how do we get out of that? Well, once again, I got x squared equal to a number. If I square root both sides, I get x equals the square root of 106. I'll use my calculator for that. Well, it's not on. Okay, so a clarification here. When we're at this level here, 53 equals 1/2 x squared. We have to get rid of this half. In order to get rid of a half, we want to turn it into a 1. If we multiply it by 2, these cancel out and it equals 1. So I'm left, and I have to do the same thing to the other side. So that's where I get the 106, no, not in Park, but times x squared. So this is 1/2 times 2 over 1. This all turns into a 1. So it's no longer there anymore. Okay, so I'm not done yet here. I have x equals 10.29. In order to get full credit here, you have to say, it says find the value of x round to the nearest tenth. So x is 10.3 if you round to the nearest tenth. I'm assuming this was multiplied, right? Someone gave me that answer. Inches. Okay, x is 10.3 inches. In order to get full credit, you have to write 10.3 inches. Okay, working on number 23. Okay, you're going to be given a piece of graph paper, and it'll say solve the system or solve this inequality, or the system of inequalities. So by graphing, so what we have to do is graph this. For the first one, for the y less than or equal to x plus 4, we're going to actually graph y equals x plus 4. And we're going to graph this, I'll do this one by slope-intercept form. Okay, we have to realize that this here means a solid line when we graph it. And it also means to shade, and most likely the shading is going to be down, but we're not sure yet. I mean, that's something we can't necessarily assume, but we'll see what happens. So how do you graph y equals x plus 4? Well, I would do the slope, which is 1, which means up 1 over 1. And I'm going to start at y equals 4, and that's going to be my intercept. So I'm going to go to the 1, 2, 3, 4, put a dot, and then I'm going to do a slope of 1, up 1 over 1, up 1 over 1. So it's basically corner to corner on your piece of graph paper. Again, I look back and I see that it's going to be a solid line. So I extend a solid line as far as I can on my paper, going through those points. You will have a straight edge on the final exam to make your line straight, and you're going to want to be accurate with these. It's possible. Okay, we're going to put arrowheads at the end of this, and let's check out the shading. I'm going to pick a point off the line. I'm going to pick 0, 0. And I'm going to put it into my original equation. So I'm going to put it in, or inequality. Is 0 less than or equal to 0 plus 4? Is 0 less than or equal to 4? And that is true. So I shade towards my point. So when I'm going to shade this way. I'm only going to do a little bit here because I don't want to mess up my graph paper for the other line. Okay. Now we have to do the other line. So that's how we graph that one. That's great. We also want to label this line here. Sorry. Y is less than or equal to x plus 4. I have my axes labeled on this. Well, it's not totally labeled, but we'll label the axes. So how do we got to graph the other one? 2x plus y is less than or equal to negative 4. Okay, this is a little bit more difficult to graph. You could move the 2x over by subtraction and graph it the same way we just did. I would suggest that you do this by the intercepts. Okay, and how to do it by the intercepts is we're going to just do an xy chart, and we're going to say, well, when x is 0, and we're going to put a 0 in for x, so 2 times 0 plus y, and again, we're dealing with the equal to, sorry, I didn't state that, we're doing the equal to, so plus y equals negative 4. So when we put a 0 in, we get y equals negative 4. So my ordered pair for that is 0, comma, negative 4. So that's the ordered pair I'm going to graph, and that's the work for it. Okay, that's go to 0 on the x-axis and negative 4 on the y. 1, 2, 3, 4. Put a dot. Color. Put a dot. Okay. Now, again, this is just one way you can do this. I'm going to put a 0 in for the y now. If I put a 0 in for the y, I have 2x plus 0 equals negative 4, or 2x equals negative 4, or x equals, divide both sides by 2, negative 2. So that's the work for that, but my actual ordered pair that comes out is negative 2, 0. All right, well, I go to negative 2 on my x-axis and don't go anywhere. That's going to be right there. Now, on the test, I know I put a greater, a less than without the equal to sign here. So on the test, beware of dotted lines. Okay, but this one is a solid line. So we're going to do the same thing. We're going to connect those two dots, and we're going to do some shading. Okay, so we've connected our dot. Now we're going to test 0, 0 for this one. So let me back this up a little bit so you can see it. So we're testing where we're going to shade for this one, for 2x plus y is less than or equal to negative 4. So we're going to put 0, 0 in again. And we're going to get 0 less than or equal to negative 4. Now, is this a true statement? The answer is no, this is false. 0 is greater than negative 4 on the number line. So we're going to shade away from 0. And when we do that, our shading is going to go this way. Now, instead of shading the whole graph, I'm just going to shade the area where the two cross. So I'm going to shade this way for my one line and shade this way for my other line. And it says mark the solution, the parts where they cross, with an S. So I'm going to put an S at that point where the intersection is. And again, don't forget your arrowheads and label this other line, which would be 2x plus y is less than or equal to negative 4. Now notice how one line shaded down. This one here was less than and it shaded down. And this one here was also less than, but it was kind of hard to see if it was shading down or right or left. So be careful with your shading. You're going to want to test it. So to get complete credit for this, you need to show, and what I basically do is I go through and do points, is this line graphed correctly? Is this line graphed correctly? Is the shading correct? Is the shading correct? Did you mark it with an S? Did you label your lines? So there's quite a few points on here that you can gain or lose if you're not careful. So again, your lines are correct. You've labeled your lines. You have arrowheads at the end. You've shaded correctly on both lines, and you've marked it with the S to get full credit here. This scratch work over here pretty much can be done. You could do some of it in your head, so it's not necessary, but it helps me to see if you made a mistake and give you partial credit. Okay, I'm recording, so... Okay, so if you weren't here yesterday, let me quickly go to the answers for yesterday's problems, if you missed it, and today's. So these are the answers to the homework questions from yesterday, and you can pause the video to check your work. I believe all these answers are correct. 17 had a little extra work to it. You're going to have to ask me about that, and I'll try to put it on another video, but right now there's no video for it. So these are the answers for yesterday's. Again, pause the video, check your work. Okay, thank you. So